Welcome again to Bungalows for Bachelors. We finished up the beams on the last video, and now we are going to think about hangers. Do we have any big beam hangers in here? And the answer is no, because there's no beams that are hanging on other beams. So we're good to go. Everything's in a wall or on a post. So what's next? Posts, exposed posts. So the front porch has some, and the back patio has one right there. We'll do the front porch first. And we will just take a look here and say these are symmetrical, so they're going to be holding the same loads. So we're just going to do one of them. So we'll go over here, create a freestanding post, call it front porch. The height of this guy is an 8-foot post. The base of it is going to probably sit on some steel plate or anchor of some kind, so we'll leave that alone. Loads, we're going to delete that load there. And I'm going to link in the front porch front to back beam reaction 1, because that's what's sitting on the post. Remember, that's on the wall. There's the picture. That's in the wall. That's on the post. Transfer. And I'm also going to bring in the front porch right to left, because that's sitting on this as well. So the left side one is sitting on the left post. Cool, good to go. Leave the 1/6 alone, standard. We're going to select, I think a 4x6 was specified in the architectural plan, a 4x4. So let's just see if that works. Should be fine, and yes. Slenderness is fine, not too tall and skinny. Doesn't fail in compression and doesn't fail in the bending from compression. So the buckling failure is what this is. So, cool. We are good to go here. So, let's go back. We've got a 4x4. So if the architectural plan specifies a 4x4, I'd probably just write some kind of note that says, oh geez, architectural post sufficient. Something like that. All right, and then I would leave that right here next to my post. So I'm good. All right, so I'm going to go to the back. Oops, that wasn't supposed to move. And look at this post. Slightly different loading scenario. So we're going to copy this because it's another post and it's a little bit faster. We'll just call it patio. Height and supports, still 8 feet. Loads, we don't have these links anymore. What we do have is the patio front to back beam. Rear support. So let's plug that in. Now we also have this guy here, and if you recall, the way we did this is we assumed this was like the other one in the front because of this area thing going on. So we did the math the same way, and it was all good, no problems. So what I'm going to do is I'm going to use that beam from the front, which is the same, which is the same 8-foot beam, but it's going to have a little more weight on it, so I'm just going to add some extra weight manually and just account for that. That's what I'm going to do. And it's going to be nowhere near capacity anyway, so it's not really going to matter at the end of the day. Got to think about the end of the day. So the front porch, front to back, I'm going to take the left reaction, front porch right to left is the front beam. All right, so it's got these loads on here. And I'm going to just add some extra weight on here. It's not, so this beam was adding 200 pounds and 243 pounds. So I'm just going to go in there, and there's no extra roof weight, but there is extra wall dead weight. So it's just extra dead weight. So I'm going to call it another 200 pounds or something. No big deal. And this is from extra gable wall. All right. I'm adding a little bit extra weight. This is not realistic at all. There's no way it'd be this much, but I'm being conservative. I'm adding the extra weight from this portion right here. Even though the weight's over, the post is over here, I'm going to add some weight as if this 200 pounds was sitting on top of it, and it's conservative and it's not really happening, but you'll see that a 4x4 is still just fine. Put this in here and I'm still good. 55% and 20% buckling, so I'm good. So what I'm going to do is I know that's good, so I'm going to take this note that the architect said a 4x4 was the one to go. I'm going to say you're good here, Mr. Architect. Good job. Your post is sufficient. Cool. All right. So because we have some actual posts, we want to think a little bit about what kind of hardware we might put on there. And to do that, we're going to just play the googly game. And we're going to think about what kind of connection is happening right here. So we've got a 2-ply beam and a 2-ply beam coming together. What kind of hardware should we use to connect them? Well, the top of the beam is going to look, I'll draw right here. Top of the beam is going to look like this. There's 1 ply. There's another ply. There's another ply. There's another ply. Okay, so this is a beam, this is a beam, and this is how they're joining together. And this is each beam is a 3-inch thick beam because they're 2 plies of 1.5-inch thick lumber. So if I have a 3x3 and my actual post is 3.5 by 3.5, I'm going to have a tiny little corner sticking out here that I'm not going to cover up with my beams. Okay, so the one that's going to look like a good one for this scenario, because we aren't really matching the width of the post or anything, is going to be this light post cap for end condition here. And this guy, we're going to put 1 on each side, and that's going to nail the beam down to the post and give it a little bit more rigidity. So that would be the one that I'd use there. So an LCE. And if I go into here, it's going to tell me what kind of options I have here. So what model? So there's an LCE4. It looks like that's the only model they make. So that's what I want, the LCE4. So I'm going to go into here, and I'm just going to write out with my text LCE4 post cap right there on that post. And I'm going to go ahead and throw those on the front too, because I have basically the same thing going on in the front. And I'm running out of room to put things, but it's okay. I'll stick that in there. All right. So I've got the post caps in there. Let's talk about built-up post sizes here. So the built-up posts are places where I have exceptional loads coming into my walls, where I need to kind of worry about how many studs I've got under my beams. So if you're dealing with something like this where you're coming into a corner and there's not very much weight on here, I mean, let's just go look at how much weight's on the end of this beam, because that'll be like a decent amount, but let's see. So if I go to the patio front to back and I look at the report, the part that was in the wall, which was the reaction 1, had only 957 pounds factored right there. So if you're not going to go, I mean, if you're under like 3,000 pounds, then you're pretty much not going to worry about it. You know, throw 1 or 2 studs underneath that, and you're good. The 3,000 pounds is kind of like the 8-foot ceiling, 3-stud post will get you roughly 3,000 pounds. So that's just kind of from experience of doing a whole bunch of posts. So you can always calculate it in here if you like, and you would do the same thing. You take the weight from here, you'd put it on a built-up post, add plies, and you would see that it would be designed totally fine. But what I'm concerned about more than that is this big beam, this ridge beam here, all right? So this is a vaulted ceiling. So I am concerned not with this one, but I'm concerned with this one because, well, first let's see how much weight's on the end of that beam. I might be concerned over here, but let's check. So let's look at our kitchen, the living room front to back report. How much weight? Okay, so 3,175 pounds. We're going to go ahead and take care of that. We're going to think about that here. So the front is a balloon framed wall, because there's nothing in here that's going to like separate the wall from the roof plane or anything like that. So the front, this whole wall is going to be framed all the way up to the edge of the roof, because it's a vaulted ceiling in here. So that means whatever the peak of this is, the stud height right there that's holding up my weight. Now I've got a 2x4 wall here, and I've got a lot of weight on it and a tall stud, so that might not work. I might need a 2x6 wall structurally. So let's check. So the first thing I need to know is how high my stud is going to be. So I figured out that I have an extra 5 feet from the roof over my ceiling. So I've got an 8-foot wall plus 5 feet gives me a 13-foot tall stud. All right, so that's what I need to know there. So I'm going to go to my software. I'm going to create a wall column because it's built inside the wall. I'm going to say front of living room beam. Exterior walls with flexible finishes, exterior walls, interior gypsum board finish. Okay, so what's I've got lap siding on there, which is considered flexible, but on the inside I've got gypsum board, so I don't want to crack that. That's the limiting factor, so I'm going to select that one. My wall height is 13 feet. Plate size, double top plate, single bottom plate, blocking. So this is on an exterior wall, so I actually know it's going to get wall sheathing nailing. So in a worst case scenario, every foot I'm going to have a nail that goes from my sheathing into my stud. So that's considered lateral bracing, right? So it's keeping the thing from shifting around. So I'm going to claim that. That's going to give me some good stiffness. Go to my loads. So this is where your location will matter because the location is going to determine the wind design speed that it's pulling in here. If you want to do it manually, it believes you can do it manually. Add a lateral load. Well, never mind. It's going to just pull by location, so I'll take it back. So it's saying, what's my tributary width? So what's my stud spacing? Well, right now it's a 2x4 wall with 16 inches on center. So every 16 inches, a stud is holding the wind load from that wall. So that's what the width of this blue here would be 16 inches, loading one stud with wind, which is going to bend it. And then I'm going to add load on top of it from my beam, which is going to be deleted out of here, and I'm going to link it if I can. That's right, I got to link it first for some reason. Link the living room front to back, reaction 1, transfer, and then delete this thing. All right, so there's my weights coming in, and got the weight on top, and I got the wind load. So let's see if this works. Right now I've got commodity lumber 2x Southern Pine number 2. I got 2x4 studs. If I use 4 of them, it's probably not going to tell me if it works or not. It doesn't like 4-ply studs. So let's try 3. All right, so here's what we got going on. 3 is fine, and it's like geometric shape of slenderness. It's not the like L over 50 or whatever, L over D, whatever that, L over D less than 50, something like that. Compression is technically not failing, but what we are failing is the buckling, 1,058% buckling failure. So that's not good. So that means we can't use 2x4s, even if we add another ply, we're still 1,000% failure here. So we're not going to make up for that with one more stud. So we're going to switch to a 2x6 wall. So 2x Southern Pine number 2, depth 5.5 inches now, 3 plies. Let's see what that gets us. We're doing better, but we still fail. But now we're at 156%. So what we're going to do we're going to try this. So if we do 2 of them, we fail. Once this loads. So I fail at 250% with 2. And I fail at 150% with 3. And it's probably not going to let me calculate with 4. Oh, it will. But I still fail. Okay. So it's not a linear relationship. You can't assume that. But so this still doesn't work. Even 4 studs. So what does that mean? Well, it means I just happen to have a tall wall and a lot of weight on it. So I'm going to have to actually make this wall a 2x8 wall and probably just three studs. I'm at 91%, so that's kind of cutting it close. It's not going to go over 90. So I'll do 4. All right, so we got that much weight coming down. We're at 67%. We're good here. So 4 2x8 studs is going to be a good post at 13 feet tall to support the weight that this beam is doing here. The beam is loading here, okay? So I'm going to come in here. I'm going to say 4 2x8 Southern Yellow Pine post. And I'm also going to say, because no one wants to see that thing sticking out. Oops. I'm also going to say make 2x8 wall. And that's because of the structural requirement. So, because of this post. We don't need it for insulation or anything, but we got to do it for this post. All right, so this side, we're going to pay attention to what's happening here at this location. How would this be framed? Well, first there's a pony wall, and then there's a shorter wall. There's the 8-foot wall. So we're going to check the load on the short column first. It should be okay as a 2x4, and the 8-foot wall, we'll see. We shall see. All right. So the thing, I'm going to draw this out here right on top of this. So we have basically, we've got the first wall framed here and the second wall here, and I'm going to add a bunch of studs in here. Basically, the top of my beam is right here. So I've got this post, and then I have the studs that are inside the wall framed below it, and it's going to be broken by the wall top plates. So I have 2 posts there. So let's do the first one, which should be fine. We'll copy this guy. Rear of living room beam. Let's call this pony. Height and supports. All right, so first of all, we're now inside. So interior gypsum board is what we don't want to crack. Height and supports. We have 5 foot in our attic. Our load is the same because the beam is symmetrical, so I'm not going to bother changing that. But I don't have wind load here, which is going to help a lot. The wind is causing some of the problem on the front wall as well. Product selection. Let's see here. 2x4s. Let's say 3 of them. Ta-da, 21%. So 3 2x4s is good when it's nice and short. It's not the weight that's the problem. It's the tall, skinny part that's the problem. And the wind that's not helping that. All right. So I know that my pony wall is good. So I'm actually going to leave this all alone. I'm going to copy it. Call this 8 foot. Go to my height. The only thing I'm changing here is my height, 8 foot. The same load's being transferred down, except what I'm going to do is I'm going to change it. So there's technically the post weighs something. So I'm going to link. Oh, I can't. Never mind. I'll take it back. Yeah, I'm going to leave it copied. And the post technically weighs something, so I'm just going to add a little bit of dead weight on here. Just say 100 pounds. Probably doesn't weigh 100 pounds, but being conservative. And 3 2x4s. What do we get? Still 38%. Okay, so we're fine. There's no problems here. So now let's look at that front wall situation again, because some other things we could change is the wind loading section of this. So if I can take some of the wind load away from the studs that are holding the beam, then I help out the situation. So let's see what kind of stuff we could do. Maybe we can get that down to a 2x6 wall. All right, so let's go front of left right beam, post here. I'm going to change this tributary width. So if I put, let's say, a stud 12 inches and 12 inches on either side of this post, then now I have a 12-inch tributary width. And load stays the same. So let's check our solutions here. So we lose a lot of bending failure there. So let's go back. Let's try the 3-ply. We're back at 71. I'm willing to bet we can't quite do a 2x6. Let's try 4-ply. Oh, we can. All right, so we can do a 2x6 wall. So simply by changing how much wind is loading that column, I am able to use smaller boards here. So instead, I'm going to go back, because 2x8's a lot of material to be using for this whole thing. That's a lot of money. So I'm going to change this. We still need to make it a 2x6 wall from the original design. And I'm going to say it's a 4-ply 2x6 post and 12-inch tributary width max. So what that means is when I frame this, I'm not going to allow any stud to go farther than 12 inches away from this thing. right? So one stud can go there, one stud go there. It'd be better if I put them even closer, but then I might as well just have a bigger post. But yeah, so that's what I'm doing there. So I'm just using different math to save some money on my members. So I'm gonna go ahead and end this and do a new video on the next one.